I'd like to show you an example of a direction of flow problem, and this is from your Galvanic cells problem set, which you'll find in your Galvanic cells folder. Alright, so here's what you've been given. You've got your diagram, same one as we've been talking about. These are the questions you'll need to answer about each of these. And we can go ahead, I think, and just maybe put labels on these so that we're more familiar with exactly what each of these is. So W is titanium metal. X is Ti2+, and we know this because NO3 is negatively charged. There's two NO3s, which means that's -2, which makes a Ti positive 2. The nickel is 2+ as well, and Z is the nickel. Alright, so our next mission is to go hunt down these values on the reduction potential table. And there is our Ti2+ plus 2 electrons gives titanium. Remember, we're looking for something that's got both of these in it, Ti and Ti2+, and that's the one I would choose, and it's minus 1.63 volts. Alright, so I'll put that one down. I'll put that one down here. Now I'm just going to write these down as reductions to begin with. And so these are E0 values that we're looking at. Now we're going to find the relevant one for nickel, which I know is going to be nickel 2+ plus 2 electrons gives nickel. Incidentally, I can figure out the number of electrons involved. If I know it's nickel 2+ and nickel, then if it's 2+, it needs 2 electrons to balance out, so you can always do it that way as well. But you always see these on the reduction potential table, so you don't really need to do that. So nickel 2+ plus 2 electrons gives nickel. There it is, minus 0.257 volts. Alright, so there's my two reactions. Now what I've got to do is figure out which one I flip that will make the reaction become spontaneous. So overall, this whole thing has got to end up being added up to being positive. As a rule of thumb, what you can say is whichever one of these is smaller, and I'm talking about smaller in magnitude, that's the one you flip. Now in this case, if I flip the minus 1.63, you see that's going to become positive 1.63. When I add that to negative 0.257, I know that that's going to work out, and it's going to give me a positive value for E0 cell, and that's what I'm looking for. So I'm going to go ahead and do that. Mind you, it wouldn't be the end of the world if you chose the wrong one, because then you could figure out it was negative and you could just choose the other one. But you only ever flip one of these, and like I said, I'm going to flip the top one. Alright, so Ti is going to become Ti2+ plus 2 electrons, and we're looking at positive now 1.63 volts. The reason it's positive is because I flipped it. And now the other one stays the same, so it'd be Ni2+ plus 2 electrons gives nickel, and that's still negative 0.257, and that's going to give me a value of 1.89 volts. No, it isn't. It's going to give me a value of 1.37 volts. But I don't really care so much about the actual magnitude of it. All I really care about is the fact that it's positive. That's all I'm looking for. Alright, so I'm going to go ahead and add these together. Alright, there you go. so there's our total reaction there, and this is the way it's going. So now we know where everything's going to flow. Okay, direction of electron flow. Well, the electrons will always flow towards the one that's plating, and the one that's plating here is the nickel, because what's happening is the nickel 2 plus is accepting 2 electrons and turning into nickel. So we know that the electrons must be flowing towards the nickel. Here's the other thing too, is that nickel 2 plus is accepting 2 electrons, and so those electrons must come from somewhere, and that's going to be B. So the electrons are flowing from here to the nickel. We also see that titanium is giving up 2 electrons, so because the electrons are on the product side here. So that's the other evidence. So B for that one. Direction of flow of nitrate. Well, nitrate, let's see, well, we've got nickel 2 plus turning into nickel, so the nitrates aren't needed on the nickel side anymore, and we've got titanium turning into titanium 2 plus, so the nitrates are definitely needed over there. So we're going to flow that through direction C. Alright, so that's where nitrate's flowing. Direction of flow of X cation. The X cation here is the Ti2 plus, and as we can see from the Ti2 plus, the Ti is actually dissolving, it's turning into Ti2 plus, which means that it's going to be flowing away from the titanium, which means that F will be the direction. We know that the nickel is plating, nickel 2 plus is turning into nickel. That means the nickel 2 plus, which is here, must be flowing towards the nickel electrode, so G is the answer there. The species being reduced. The species being reduced is the one that is going down in charge. So you see nickel 2 plus is going to nickel. The other way you can look at it, it's the one that's accepting or gaining electrons. So the electrons are on the reactant side. So that must be the nickel 2 plus is the one that must be being reduced. Remember, species oxidized or reduced will always be one of these reactants in the main reaction. Okay, so nickel 2 plus, that's going to be Y, will be the answer to that one. Species being oxidized, that will be the one that's going up in charge, so this is going from 0 to 2, so it's being oxidized. The other thing is that it's losing electrons. Oxidation is loss of electrons. The electrons are on the product side, so it's going to be titanium, and titanium is W. Okay, reducing agent. The reducing agent is the species that's causing the reduction. And the one that's being reduced is the nickel 2 plus, and it's being reduced because the titanium is giving it electrons to be reduced with. That means the reducing agent is W. Oxidizing agent. The oxidizing agent is the species that's causing the oxidation. Now the nickel 2 plus is accepting the 2 electrons that the titanium is losing. So the nickel 2 plus is actually causing the oxidation of the titanium, so that answer is going to be Y. And it's not a coincidence. The reducing agent is always the species being oxidized, and the oxidizing agent is always the species that's being reduced. The anode and the cathode, these are both electrodes. Oxidation occurs at the anode. The one that's being oxidized is the titanium, so the anode is W. The cathode is the electrode at which reduction is occurring, and the nickel 2 plus is being reduced to nickel, so reduction is occurring there, and it's always the electrode, so that's going to be Z. Alright, so there you go.